Welcome to Stadd lecture series. Today's topic is design of Raft foundation in Stadd. Let's go to Stadd. Let's open a new project. Give the name as Raft Footing. Next, finish. Let's select the node. And translation and repeat. Link step. Okay. Now select this beam and again translation repeat. Let's delete these two beams. Again select nodes and translation and repeat. Link step. Again select node, translation and repeat. Link step. So our framework for the Raft foundation has finished. Now we have to form our slab. Before going, first we have to assign property. Point 0.6 depth, 0.6 breadth. Add, close, assign to view, assign. So the property has been assigned. 600 by 600 beam property has been, concrete beam has been assigned to this. Now we have to form the slab. Before forming slab, we have to generate some points, as we will do the slab by joining 4 noded plates. Select node, translational repeat. Select node, translation and repeat. Now we will add 4 noded plates. One thing you have to give in mind that our direction of rotation should be same in time of creation of these plates, because the local axis formation, direction of local axis formation depends upon this direction of formation of slab. If we rotate, if we form 4 noded plates in different direction, then the local axis will be different. So we have formed the plates. Now we have to give sectional property to the plate. Point 3 meter. I am giving property. Assign to view, assign. So 300 mm slab property has been assigned to all the plates. Now let's look at the direction of local axis. So look, the x direction, all the x direction has been in the same direction, as the formation of orientation of our slab was in same direction. X direction we see in global z axis, and y direction, local y direction we see in local in global x axis. Now let's create a load case. Dead load, let us add some point load, nodal load in the dead load case. Minus 900, $950, $990, 1000. Now let's assign the point loads in the footing. So load has been assigned to the 4 points, that is in the column position. Now let's do generate surface mesh, so that these plates can be subdivided into small parts, small plates, so that we can provide foundation to their joints. Quadrilateral meshing, let's divide 6 parts, so that each plate will be of 250 by 250 millimeter size. Apply. Look, the plate has been subdivided into 250 millimeter by 250 millimeter small plates. Now let us divide another plate. Sorry, there has been some mistake. Let's undo. Then again let us do the meshing, quadrilateral meshing. Apply. Look, it has been properly applied. Again quadrilateral meshing. We have to divide each direction in 6 parts, so that 250 by 250 millimeter element is formed. Parts, 6 parts, 20 parts, 6 parts. Quadrilateral meshing, okay, no, 20 parts, 20 parts, 20 parts, 20 parts. Apply. OK. Again, let us mesh the following plate. Quadrilateral meshing. OK. No. 20 parts, 6 parts, 20 parts, 6 parts. Apply. OK. Quadrilateral meshing. OK. No. 6 parts, 6 parts, 6 parts, 6 parts. Quadrilateral meshing. OK. No. 6 parts, 20 parts, 6 parts, 20 parts. Now only one remaining plate. Let us mesh it. Quadrilateral meshing. OK. No. 6 parts, 6 parts, 6 parts, 6 parts. Apply. So all our meshing has been completed. All the plates have been subdivided into 250 mm by 250 mm plate. Now let us assign foundation. First of all, let us create foundation. Our foundation will be plate mat. Direction Y. Modulus. Now how will we calculate modulus? We will calculate the subgrade modulus in the following way. First, we have to take the bearing capacity of foot soil. In our case, bearing capacity is 90 kN per meter square. Then we have to divide the bearing capacity with allowable settlement. In our case, allowable settlement is 75 mm, that is 0.075 meter. Dividing, we get 1200. So our value is 1200 kN per meter square per meter. So all the footings has been assigned. This is the rendered view of our raft footing. These are the beams, 4 beams, and in the middle part and in the side part we see the slabs. Perform analysis with no print option. Let's save our file and then proceed to run analysis. Some errors has come. We have to see the errors, where the errors have come. We have rerun the analysis and found no error. Now let us go to the post processing. In post processing, let us go to beam. In beam, we see the bending moment diagram. First of all, we have to uncheck those supports, and thus we can see the beam bending moment diagram of beams. You can rotate the figure, and thus you can see the bending moment diagram of the raft footing beams. We can also see the shear diagram of footing. The values can be obtained from result, view value, beam result, shear, annotate. Look, all the values has been shown. By maximizing the views, you can easily see those values and can do the shear design of the beams. The same way, you can also see the values of bending moment diagram. Look, these are all the bending moments of value of the bending moment diagram, from which you can design the bending of beam, footing beam. Now let us go to the plate. First of all, let's go to base pressure. This way the base pressure is shown. Newton millimeter square. Let's change the unit to meter kilonewton. Okay. Again, let's go to base pressure, apply. These are the values of base pressure. Minimum is 0.02 Newton per millimeter square, maximum is 0.03 Newton per millimeter square. Let's go to mx, local, apply. These are the mx local value in kilonewton meter per meter. From the colors, you can follow what is the value of bending moment in local x direction. Similar way, you can see local my bending moment. So by determining the mx and my local bending moments, you can design the slab of raft footing. So this is the end of this lecture. Thank you.